So picture this. You've built your RAG system, but when you ask it a question, it retrieves like half a sentence of context and then just hallucinates the rest. Frustrating, right? Well, the problem usually isn't your LLM at all. It's actually how you broke your data down in the very first place. Today's explainer focuses on mastering the art and science of chunking for your Retrieval-Augmented Generation or RAG systems.
Welcome to the explainer. Today, we're diving deep into RAG chunking methods, the taxonomy and decision framework. Look, if you want your AI to pull up highly relevant information without totally missing the point, you absolutely need the right segmentation strategy. We're going to break down exactly how you can ensure your system is finding the context it actually needs every single time. Here is our roadmap for today. We'll start with the core RAG chunking methods, then move on to choosing your chunking method, and finally, we'll wrap up with semantic chunking, pros and cons. Let's get into it.
All right, Section 1, Core RAG Chunking Methods. Think of this as the RAG chunking menu, where we escalate from the most basic tools all the way up to advanced AI-driven techniques.
Okay, let's dive into this with our first foundational method, fixed-size chunking. This divides your text into completely uniform segments based on a rigid, predefined token or character length. You ask for 500 tokens, it cuts exactly at 500 tokens. Boom. But because this method is entirely blind to meaning, it might chop a crucial sentence literally right in half. To fix that and maintain context, you have to incorporate a slight overlap, just making sure no critical information is severed at that boundary.
Now, stepping up the complexity a bit, we have recursive chunking. Instead of blindly counting characters or tokens, this method actually respects the formatting of your text. It iteratively splits things up using natural separators. Think paragraph breaks and then sentence breaks to preserve the logical boundaries the original author intended. It recognizes that human language is structured into distinct thoughts, and it really tries to keep those thoughts intact within the chunks.
And this brilliantly illustrates our next major leap forward, semantic chunking. Here we completely abandon structural markers. Gone. Instead, we group text based on semantic similarity using embeddings. Basically, the system evaluates the actual meaning of the words, grouping sentences that discuss the exact same concept into highly coherent, meaning-based chunks. It's a massive shift, moving entirely from structure over to substance.
Finally, we reached the most advanced tool on our menu, which is Agentic Chunking. Here, AI agents do the heavy lifting to dynamically segment text in a truly task-oriented way. The agent understands what the ultimate goal is, creates semantically coherent chunks, and, critically here, tags them with metadata. It acts kind of like an intelligent filing system, which massively enhances retrieval relevance later on when your RAG system comes looking for answers.
Moving right along to Section 2, choosing your chunking method, the decision matrix. So how do engineers actually deploy these tools in the real world based on specific criteria?
Well, choosing a method really comes down to a few core criteria. First, you have to look at the nature and structure of your source documents. Are they neat and formatted, or just a messy wall of text? You also need to weigh the capabilities of your embedding model against your specific application needs. Ultimately, you're constantly balancing chunk size. You want it large enough to capture meaningful context, but small enough to fit within your model's constraints for efficient processing.
So the crucial point is this. When you're dealing with structured, well-formatted data, or really highly complex tasks, you absolutely require semantic or agentic chunking to ensure logical boundaries and preserve that context. Conversely, for simpler cases, fixed-size chunking is entirely sufficient. Seriously, you don't need to over-engineer a solution if a basic, uniform token split with just a little overlap is going to get the job done for your specific need.
Every single method we've discussed today is ultimately trying to balance what I like to call the holy trinity of RAG chunking. You want high retrieval relevance, meaning getting the right answer, and you want context completeness, making sure that answer actually makes sense. But you are constantly fighting against computational efficiency. It's this perpetual tug-of-war between high accuracy and compute cost.
All right, Section 3, semantic chunking, pros and cons. Let's do a deep dive and really scrutinize this highly debated method.
The primary objective here is straightforward. Semantic chunking groups text based on meaning, creating coherent chunks that enhance retrieval, relevance, and context preservation. I mean, who wouldn't want their documents sliced up perfectly by meaning so the AI can easily read coherent thoughts? Sounds great, right? But as we know from our decision matrix, nothing in engineering is without trade-offs.
Now, what's really interesting about this slide is seeing those trade-offs side by side.
The clear advantage of semantic chunking is that it aligns perfectly with natural topic shifts. If a document changes subjects, the chunking adapts, which massively improves retrieval for complex queries and reduces information loss across those boundaries. The cost, however? It is highly computationally intensive. It requires running entire embedding models just to figure out where to make the cuts. Plus, it ironically struggles with highly complex or poorly structured documents. If semantic boundaries are unclear to begin with, the embedding model will have a really hard time figuring out where one thought ends and the next begins.
And that brings us to our final question. We've explored the straightforward fixed-size chunks, the logical recursive splits, the meaning-based semantic groups, and those highly advanced agentic approaches. You've seen the decision matrix and the really delicate balancing act between relevance, completeness, and efficiency. So, looking at your own AI data challenges, your own source documents, and, let's be real, your own computational budgets, which chunking method will balance your next RAG task? Think about that as you design your next system. Thanks so much for joining me for this explainer. Keep learning, keep structuring your data, and I'll catch you on the next one.